Hi everyone, I'm Naveen from Nutanix. Today I'm going to talk about VM migration enhancements that we have upstreamed. Some of the enhancements are merged and some are under review. So along with me, my team members Shibir and Mansi also contributed to these enhancements. Yeah, here is a quick agenda, a brief introduction why we have to do these enhancements, followed by the actual enhancements. So let's quickly go through the introduction. Yeah. So to support VM live migration use cases, like OVN already has an option, requested chassis. So it is exposed at a logical switch port level. So it is very useful to reduce the packet or almost eliminate the packet downtime or the traffic downtime when doing live migrations, right? Within the single availability zone. So which is managed by single OVN instance. Right. So our use case is to support VM migrations, live migrations across multiple availability zones, which are managed by different OVN instances. So that's where we have landed into some issues. So we are targeting the near zero downtime that we can achieve something similar to requested chassis port. Right. So apart from these, like there is another use case where we wanted to reserve zone before migration in the OVN controller. So our use case is to do like contract entries migration as part of the VM migration workflow, right? So we will talk about these enhancements in details. Yeah, yeah. So let's quickly look into the topology, right? So in this topology, like there are like two availability zones, A and B, and the subnet 192.168.1.4 1.0/24 exists on both the availability zones. So it is stretched using an external VTAP gateway. So as you can see, the internal interface of the VTAP gateway is on either side. It is connecting to a logical switch, right, which is the subnet which is getting extended, right. In this, so in our use case, this port has unknown address, marked address type as unknown. The the internal interface of VTAP gateway, because the remote, like if you take AZA, all the MAC addresses of availability zone B, right, will be learned on this. So there are like more than one MAC we need to learn, right? So and the outside interface is what it's external interface, which is on which VTAP gateways are communicating, right? So this is managed by one OVN instance, availability zone A, and B is managed by another OVN instance. That's about the topology, right? Let's talk about the first issue we landed into, right? So yeah, so in this case, VM A1, right, which is initially on the availability zone A, now it's getting migrated to availability zone B. So as part before migration, like so we need to prepare the destination node, right, for this VM. Like we need to create an interface for this VM, and then so we'll set the iFace ID. So when iFace ID is set, then automatically OVN controller will download all the flows associated to this, and then the port binding records, port binding table is updated. So once that is done, right, all the VMs on this availability zone B will think, okay, the port is locally reachable, and will try to send the packets to this, right, since the port binding record is updated, right? So which will lead to packet loss, since this VM is still under migration, right, and it is actually the VM is residing on the availability zone A, right? So for this, so what we have done is, so we have introduced a new option called packet clone type. Currently, it supports only one value. It's enum of one value, MC unknown, which is multicast unknown. So what it does, when we set this option on this LSP, which is under migration, right? So then automatically any packets destined to this particular port will get cloned to all other ports in that subnet that have address of type unknown. So in this case, this VTAP gateway internal leg or internal port has unknown address. So this is how the one packet will go local and one packet will get tunneled. right? And that's how it reaches the other side, availability zone A. So this is how like we addressed the packet loss for this issue. And so let's talk about the second problem we have hit this, right? So now the migration is completed, but the CMSP or the CMS plugin can take some may take some time, like to clean up the resources on the source side, right? It could be like few seconds, right? But we are targeting a near zero downtime, right? So in this case, what happens is once the VM is migrated, the VM will send the GAR packet, right? So then the GAR packet, since it's an L2 broadcast packet, that also will get tunneled, and it reaches here, availability zone A. So here, so OVN has a proxy ARP rule in for all the logical ports that it is managing, right? It is assigning IPs and all. So, so the logical switch, right, will reply to this. The proxy ARP rule in this availability zone A logical switch will reply to this GAR packet. So, so even though the VM is migrated, right, like it, so the proxy ARP rule is not yet deleted because the interface is not yet cleaned up. So then the VTAP gateway MAC table will get polluted. Like it thinks, okay, the VM MAC A1 is still on this E0 port, right? So actually it should have been on this tunnel port since the migration is completed. Right? So this also cause some packet loss, whatever time it takes for CMSP to clean up these interfaces, right? So for this, what we have done is, so we added one more option to disable ARP and neighbor discovery response at a logical switch port level. So site as part of migration, if this is also set on the same LSP, so what it does is like it will not install the proxy ARP rule. So for this particular IP or for this particular VM, so then so it will let the ARP packets or the GAR packets, it will let the VM to handle. So even though the GARP is coming and then it's getting flooded over VTAP gateway, right? So the VM is not, since it is already migrated, there is no one, there is no VM actually physically here to reply. No one is owning this IP, right? Like no one will reply. So the VTAP gateway, yeah, it learns on the right interface, right? In this case, once the migration is complete, as part of this GARP itself, it will learn, okay, on this tunnel interface now, this MAC has moved, right? So this addresses the second problem. Yeah, so the next two enhancements are very specific to a like very pointed use case, but we just wanted to present in case if someone landed into same, these are useful, right? So again, the topology, everything is same. The only difference here is, so for any reason, if the multiple VMs in this structured subnet has a fixed MAC and also some unknown MACs, right? Like which OVN has to learn at runtime. So along with the fixed MAC, if we configure this port with unknown address, so then so then what happens, right? Like if sorry, it's not highlighting. Oh, yeah, sorry. Yeah. So like let's say all VMs have a fixed MAC and also unknown address configured, right? Like if we use packet clone option in this case, it will cause a lot of packet duplication, right? Like we just want to avoid that. So for that, so what we have done is so we avoided. So we added a force FDB lookup option. So as long as the port has unknown address configured, so irrespective of whether whether there are fixed MAC or not, you don't install like the static flow rules in the L2 in the L2 lookup stage of the logical switch pipeline. So we make OVN to always learn these MACs to FDB table, right? Irrespective of fixed MAC is there or not, like all MACs are learned. So this will avoid, so this will not install any static ARP rules and all, right? And so we don't set the packet clone option. So we are letting basically the based on the FDB table, like wherever the VM is, right? Like whenever the MAC learns, accordingly, the packet will get traversed. So yeah. So in this case, so we just enable the force FDB lookup. So as long as it's on the AZA, the packet will go there. Once it moves and the RP or RP is sent, the packets will start moving here. Right. So yeah, this is also so an extension to the same like pointed use case. So here the problem is on the source side. Again, the CMSP, once the migration is complete, the CMSP will take some time to clean up the record, right? The interfaces on the source side. So till then, whatever the entries learned in the DB table of the OVN on the availability zone A, so they still point to the old they are stale. Basically, they are not like they are not evicted yet. So for this, we proposed an enhancement to clean up these FDB table entries when the port is down, right? Once the migration is complete, right, the port will be down. The QME will bring down the first port here, and then it will bring up the port here. As long as the physical port is down, evict the entries. So this patch is under review, and we have some comments from upstream, like Dimitri and Newman has suggested some other better approaches, like which we are internally reviewing. Yeah. So this is still under, not yet much. So so yeah, this is the last enhancement. Yeah. So we have a use case so where we want to reserve in the OVN controller for the upfront the zone upfront for the upcoming for the ports that will get deployed right in future. So the use case for this is so as part of VM migration, like we wanted to do contract entries migration also. So as and when as part of destination node is getting prepared for the migration, right? Once the interface is created and all, we want OVN controller to reserve the port. So without even before the port binding and all happens, right, on this. So before that only we want to reserve. So for this, what we have done is we have added a new key like reserve CT zones to open vSwitch table, which OVN controller process it, and then it takes basically list of ports for all those ports along with the existing port binding. So it will reserve the zones and it will store in the same table that it or same key in the external IDs that it is storing today, so that the CMSP can process that information and start migrating the CT entries to that particular zone, right? So this is our use case. Yeah. Yeah, that's it for the talk. Any questions?
Okay, we're a bit over time, so I think we have time for one question, maybe. Okay, thank you, Alish, for ceding to Dimitri for this one.
Why aren't you using OVN IC? Why are you using OVN VTEP? Is it because of the need for VXLAN?
I can't hear.
Why are you using OVN VTEP gateways instead of OVN IC, OVN interconnect, native interconnect?
So yeah, so this is an existing thing like what we have today. So we are using a third-party VTAP gateway, like which we want to continue to support the deployments with that.
Okay, I'm asking because the packet clone type option that can be avoided with OVN IC if you can just use multiple requested chassis.
Okay, so we need to be honest, we need to look into that.
Okay.
Yeah. So it supports touching the same subnet and all of
yes.
that, is it? Yeah.
Yeah.
Okay. Yeah, we need to look into that. Yeah.
Thanks.
Yeah.
Okay, let's thank our speaker.